I will evaluate the definite integral of this rational expression. Let me first take out the rational expression to resolve. You can see this is a proper rational expression in that the numerator has power 1, it is smaller than the denominator which has power 3. So if you can see the denominator has a common factor of x, I am going to try to factorize that before I resolve. After taking out the common factor, I can see that this is a perfect square. So I'm going to completely factorize this denominator before I start to resolve into its partial fractions. So now that the denominator has been completely factorized, I can see that there is a linear term and there is a repeated linear term. So I will resolve this into 3 fractions. One of them has got a linear denominator. Then you have the repeated linear, where you keep the original power and repeat it, duplicate it, but with a reduced power. For a denominator that is linear, we choose constant on top. For repeated linear, we also choose constants in the numerator. So to find the value of a, since the denominator is linear, I can use cover-up rule. For the repeated linear, I can use cover-up rule for b because the denominator is the original form of the repeated linear. This is the repeat of this, which means that I cannot use cover-up rule to find c. So to find a, I need to cover up x. So let me copy the original expression but cover up x. And whatever I covered, sub to be 0. So I have negative 4 over 4, which gives me negative 1. Do the same for b. To find b, I cover up x minus 2. So I copy the original expression, but cover up x minus 2 squared. So whatever I cover up, let it be 0. Hence, for x minus 2 to be 0, x must be equals to 2. So substitute this inside. I have 6 minus 4 over 2, which is 1. So I have the values of a and the values of b. Now let me find the value of c. To do so, I will take this denominator and multiply across. That will help me to get rid of all the rational expression. All the fractions will be gotten rid of. So now I'm going to take this term and multiply it to each of these fractions. The first fraction multiplied to this term, can you see that x can be cancelled? So I'm left with this. When I multiply this term to this fraction, can you see that x minus 2 square can cancel with this x minus 2 square? So I'm left with this. And multiplying this term to the last fraction, x minus 2 will cancel with one copy of the x minus 2. So I'm left with one more copy. Now expand this completely. So to find the value of c, I'm going to compare the x squared term. So let me look for the x squared term, which is here and here. On the left, there is no x squared term, so the coefficient is 0. On the right, I have ax squared, hence the coefficient of a, and also cx squared, hence the coefficient of is c. Since I know the value of a is negative 1, I'm going to put in the value of a as negative 1 and find the value of c. So I have a, which is negative 1, b, which is 1, and c equals to 1. I'm now going to put it back into my partial fractions and integrate them. So instead of integrating this rational expression, I will integrate their parts, which is all these smaller fractions. I have a over x where a is negative 1. I have b over x minus 2 squared where b is 1. I have c over x minus 2 where c is 1. So I can see a logarithm, I can see another logarithm. These will both give me ln. This is actually power minus 2. Maybe I rewrite it properly first. So integrating negative 1 over x is simply negative ln x. Integrating this, increase the power by 1, divide by the new power. Integrate this is just ln also. And I don't have a constant because this is a definite integral. So my limits, my lower limit is 4 and my upper limit is 5. Before I substitute the limits, again I want to make this look better. Okay, so now I'm ready to substitute my upper limit. And substitute 5, I got 1/3. Substitute 5, I have ln 3. And then I will subtract away the substitution of the lower limit. So substitute 4, ln 4. 4 minus 2 is a half. And a 4 minus 2 here as well. So once you press the calculator, you will get this answer.